Hello everyone, my name is Gaurang Gupta and today we will be doing another machine learning project which is mobile price classification. In this we have to predict the price of the mobile based on certain parameters. So here in train file you can see we have certain parameters like internal memory, mobile weight, number of cores, etc. and we have to predict this price range. Now the price range is given to us in classes 0, 1, 2 and 3. 0 being the cheapest and 3 being the most expensive phone. So in the test file what we have to do is we have to predict the price or you can say price range of the phone based on parameters which we are going to train from his here the train file. So it is a problem of multi-class classification. So now let's move on to the code. So first we will import the necessary libraries. So import numpy as np, import pandas as pd, import os from sklearn.preprocessing, import standard scaler from sklearn.model-selection, import train test split and grid search cv, not cv from sklearn.svm, import svc from sklearn.metrics, import accuracy score and confusion matrix from sklearn.linear, import logistic regression from mlextend.plotting, import plot confusion matrix, import matplotlib.py plot as plt from sklearn.ensemble, import forest classifier from sklearn.tree, import decision tree classifier from sklearn.neighbors, import kneighbors classifier from sklearn.ensemble, import AdaBoost classifier, import xgboost as a xgb from sklearn.gaussian process, import Gaussian process classifier from sklearn.gaussian process kernels, import rbf from sklearn.ensemble, import gradient boosting classifier. So now let's run our code. So here you can see our code is executed correctly. So now we will get the file paths. So for dir name, comma, underscore, comma, file names in os.walk slash kaggle slash input, for file name in file names print os dot path dot join dir name comma file name. Now let's run it. So here you can see we have paths of training and test file. So now let's load the data. For this we will use train data equal to pd dot read csv and then pass the train path. So same for test equal to pd dot read csv and then we will copy this test path, paste it here. Then test data will be equal to test data dot drop id and access will be 1. Then we will print the list of columns of training data, train data dot columns, and we will also use train data dot head to see some rows of data. So now let's run it. Here you can see we have a list of all the parameters in the train data file. So here you can see we have different parameters like battery, power, price range, etc. And we also printed the first five rows of our train data frame. So now let's move on to pre-processing of the data. So for pre-processing we will use std equal to standard scalar, then y will be equal to train data price range and x will be equal to train data dot drop price range and access will be 1. Then x will be equal to std dot fit transform x. Now let's run it. So our code is executed correctly. Now we will check different models. Now for this we will first have to divide our data into training and testing. So xtrain, xtest, ytrain and ytest will be equal to train test split x y. Test size will be 0.2, that is 20% of data will be test data and random state will be 0. Then we will define an array or a list of models. So first model will be svc and then its name, support vector. Then second model will be logistic regression and its name. Third will be random forest classifier, random forest, then decision tree classifier, decision tree, then k neighbors classifier and the name, then xgb classifier objective will be binary and logistic random state will be 42 and the model name will be xgboost. then ADA boost classifier, we will define a parameter n estimators which will be 20. You can give any value, so let's use 25 for this, and ADA boost, and the last model will be gradient boosting classifier. N estimators will be 50, learning rate will be 0.1, max depth will be 10, and random state will be 0. And then its name gradient boosting. Now finally the last model, it was second last model, Gaussian process classifier. Kernel will be RBF 1.0, and random state will be 0. Random state equal to 0. Then Gaussian process. So for each model we will first get the name, which will be I1, then model will be equal to I0, then we will print the name, model dot fit xtrain ytrain ypred will be equal to model dot predict xtest, then print accuracy score y test and y tret, and we will multiply it by 100 to get it in percentage. CNF will be confusion matrix y test y pred fig comma ax will be plot confusion matrix confmat equal to CNF. Then PLT dot show, and to give some space I will also print a new line character. So now let's run this code. Control enter. So here you can see it is printing accuracies of different models and also plotting their confusion matrix. So we have different models, like support vector is giving 89% accuracy, logistic regression is giving 95.5% accuracy, random forest, decision tree, k nearest neighbor, XGBoost classifier, XGBoost is giving 91.5, ADA boost classifier 69%, 87%. So it is processing for Gaussian process. So now the code is executed completely, and we also have accuracy and the confusion matrix for Gaussian process too. So it shows an accuracy of 72.5. Here you can see with all the models, logistic regression is the most accurate. It is giving us 95.5% accuracy here. So now we will optimize this model even further to improve its accuracy. We will optimize the parameters of logistic regression model. So let's move on to optimization of our model, optimizing best model. So for optimizing the best model, first we will define a variable which is hyperparameters. It will be a dictionary which will contain the parameter and its value. For example, we have penalty, and we are using only one value, which is L2, and the other value is C, which is 0.01, 0.1, 1, 10 and 100. Then we will define the model, which is logistic regression, then grid search equal to grid search CV model and the hyperparameters and CV will be 5. Then we will fit the data, so grid search dot fit xtrain ytrain will print the best parameters which grid search has found. best pa- Best params, not best estimator, best params, and we will also print grid search dot best score. Then we will get the best model, which is grid search dot best estimator, and we will then get the predictions. Ypred equal to best model dot predict, not fit, predict x test. Now let's run it. So here you can see we got the wait a minute we got the values for our model at which it is performing the best, which is c is equal to 100 and penalty is L2, and we also got the score, which is 97.125%. So let's calculate the accuracy to check whether the score is actually right, or it is just some hypothetical score. So it is just checking that our mod that grid searcher has actually optimized our model. So we will define a variable which is accuracy equal to accuracy score by test by pred, and we will print it accuracy. So now we printed it and we got 97%. So it is close to the value we got here, 97.125%. So yeah, that's good. Now let's plot the confusion matrix for this model. So for this, we'll define a variable cnf equal to confusion matrix y test y pred, then fig comma ax equal to plot confusion matrix confmat equal to cnf, and then plt dot show. Now let's run it. So here you can see wait a minute. Here you can see we have the accuracy, and we also have our confusion matrix. So here you can see most of the values are predicted correctly because it is also showing 97% accuracy. So it is a visual representation of that accuracy. Now we will predict the values for the test file. Let me show you what I am talking about. This file. So now we have to predict for the test data. So let's predict for it. So for predicting, first we have to do some data pre-processing on test data too. So std.fit transform test data, then ypred test equal to best model dot predict test data ypred test. So now let's run it, and here you can see we have values for the mod for the test file. Your values can be different because again it is predicting. So if the values are not exactly equal to this, you don't need to worry, it can be different. So but the accuracy should be greater than or equal to this 97%. If you find any greater accuracy with some different model, do comment in the comment section because I will love to see that. So for now our project is complete, and we have coded all the sections. Thank you very much for watching the video. If you like this video, please do share Like and subscribe to my channel. Thank you very much.